Thank you very much for coming in my talk, and thank you for having me here. So this talk is all about my research done towards browser security and bypassing the core rule policies implemented into it. So we are not deep diving into more of browser exploitation, but we'll be having a look on bypassing the core policies which are implemented in this case. So again, welcome to Call of Duty Modern Browser Warfare. Before we get started, this is a little bit about me. My name is Dhiraj Mishra. I work for a company based out in Dubai, and I blog at inputzero.io and tweet at randomdhiraj. So this is a very much high-level overview of how a general browser works. So I will be going to each of the block one by one, and I'll make sure that you guys are not bored on this. So if you talk about user interface, now user interface is something which you see in your browser. Start from your navigation pane, back button browsing, your address bar, your preferences, settings of the browsers, and so on and so forth. So the UI block is responsible to showcase all those things. When we talk about browser engine, now this is something which facilitates between the rendering engine and the user interface. The third one is rendering engine. Now, when we talk about rendering engine, it does a lot. It actually does a lot of work basically. So rendering engine is something which renders web content and web pages for you. Start from the JavaScript, HTML, whatsoever you do, it is being rendered by the rendering engine. Now, a rendering engine would actually have three components in this case. One is networking, the other one is JavaScript interpreter, and the third one is UI backhand. So then the networking block is responsible for handling the protocols. So if you browse to HTTP, it's a protocol probably, and HTTPS, then it has FTP and so on and so forth. So the protocol handling stuff has been done by the networking block, which is one of the key component of the rendering engine. Apart from that, networking block is also responsible for your DNS resolution. So resolving the DNS basically. Moving on to the next one, we have JavaScript interpreter. Now, JavaScript interpreter is when you write few lines of code and you miss out certain division tag, HTML, and so on and so forth. That small little exception is been handled by this certain block in the part of a browser. So that is being actually handled by JS interpreter. The third one is UI backhand. The name itself says that whatsoever you want to visualize, it creates it for you and push back to the user interface so that what is being represented by your browser can be done and handled by the UI backhand. Talking about the another one, which is data persistent, that is another key component of browser engine. When we talk about the data persistent in this case is when you visit any website and you log in and you say remember me in your cookie or credentials, that small little part is being taken back to a space, and that space is known as data persistent layer in the browser. So this is a very high level overview of how a generic browser works and with the certain blocks. Moving on to the next one, when we have browser, there would be origins. Now, this is just to give you a quick idea what origin is. It's a combination of scheme, host name, and port. Now, scheme can be any protocol what you are using, and host name is something, it's a name with TLD, and the port is the random port specified by the end user. So it's a combination of scheme, host name, and port together called as origin. So let's talk about what origins are and what same origin policy is. So then we will be moving on to the bypasses in this case. So if we talk about same origin policy, so same origin policy is one of the most important policy which is implemented in browsers in the modern browsers. So what happens is, let's suppose a scenario where a user or Alice is browsing site.com in any random browser, and parallelly it has open another tab which says site.a.com. Now, the policy implemented in browser states that there should be no data transfer between the two different origins. So site.com is one origin and site.a.com is a different origin. So let's suppose a scenario where site.a.com is hosting some malicious XHR request, which is like a normal GET request, and try to fetch data from site.com. The SOP which is implemented in the browser will actually deny it, because that's how the policy has been implemented. So same origin policy was implemented back in 1995 by Netscape Navigator, now owned by Mozilla. So that's why it is very important. If same origin policies are not in place, there could be a real example where you are navigating to facebook.com and you have opened another tab called evil.com, and evil.com may have certain JS payload which try to grab your session cookies from Facebook and may not perform the further malicious activity. So that's why SOPs are one of the core components when we talk about browsers. Moving forward, we are going to talk about what same origin policy is and what bypasses did I figure out during my research. So I found out two same origin policies in different browsers. The one is Samsung Internet Browser, and the second one was the DuckDuckGo, which is a privacy browser. So without further delay, let's jump into the exploit code. So how did I figure out this one? So I was trying to play around with different functions of JavaScript, such as window.open, inner HTML, and so on and so forth. So if you have a look on the exploit, I have utilized onClick and created a function go. Now the function go defines multiple variables and etc. So I have a defined variable called x which opens a URL. So using window.open function, I can open a URL, and in this case the URL is https www.google.com/csi. And I have modified the inner HTML content using the inner HTML function in this case. So what happened is, I'll demonstrate basically. So your browser would point to google.com, but you have already played with the inner HTML function that will basically showcase whatsoever attacker is being punched in the malicious code. So if you look the inner body.inner HTML, it says please log in with the x.prompt, and it will give you a prompt for email and password. And that email and password would be carried back to the attacker's origin. So this was reported to Samsung and they pushed a patch for this, but moving forward, after finding out this issue in SOP bypass, I ported this to an MSF module, to a Metasploit module, so that it can be utilized. It's my personal opinion, the exploit code which I figured out can be used in the legacy Android cell phones, and the inbuilt browsers may be vulnerable to SOP bypass. So that's why I went ahead and ported this to an MSF module. So if you open your Metasploit back in home, you can navigate to auxiliary gather Samsung_browser_SOP bypass.rb. Now this module basically initiates a redirect to a child tab. And I let you know because I have a video POC for this. It initiates a redirect to a child tab and rewrites the inner HTML content by giving the fake pop-up. So thanks to the MSF team for helping me to get this ported. Here is a small understanding about how the portability happened to an MSF framework and how did I contribute it to Metasploit. So I created two JavaScript functions. I defined two JavaScript functions in this case. We will be talking about custom JS later because it's a very interesting part for this module which I have ported to an Metasploit. If you see, there is this called JavaScript equals, where I have inserted my malicious JS payload, which you seen in the previous slide. It basically gives 4 of 4 error and says oops, something went wrong, and gives you a prompt for email and password. And once the email and password has been punched, it travels the password back to the attacker's terminal. So in the second block, if you see where x equals window.open, now I have utilized the default libraries of Metasploit. When say window.open hash data store and the target URL, this is something which you punch by your own. So in our case, it would be google.com. If you want to spoof certain different origins, you can put github.com or any other website. There is a small little function called store_cred. So if you have done any pen test so far in your client facing and you have used Metasploit, whatsoever credentials has been gathered in your Metasploit database credential, so this function is responsible for that. Even my Metasploit module utilizes this machine so that once you spoof the origin and gather the credentials via fake pop-up, that credentials is stored back to your Metasploit workspace. So I have utilized store_cred in this case so that the gathered credentials with the origin, spoofed origin, can be stored in your Metasploit DB. So I'll show the video POC in this case, but after everything went perfect for Samsung Internet Browser, I have a habit that I use the same exploit for different vendors. I went ahead and I started adding the same exploit to different browsers. And I found luckily DuckDuckGo to be vulnerable for one of the SOP bypass. I tried Mozilla, I tried Safari, but none of them were vulnerable in using this POC, but DuckDuckGo was. So I won't explain the same thing again, but this is how a portability of MSF look like. I'll just quickly show the video POC. So this is my MSF console, and in the other side I'm running Genymotion, which has a vulnerable version of DuckDuckGo. I search for my module, which is Samsung search SOP_bypass. It says auxiliary gather Samsung_browser_SOP. You say use 0, and there are tons of options over here. So if we need to set our SRV host in this case so that the malicious web server would be hosted on that IP address. So that's my private IP. And if you remember the exploit code which we talked previously, we are setting the target URL in this case, and the target URL is https www.google.com/CSI. We are trying to spoof the origin of google.com, and we set the URI path to / so that no random directories are available after /. Once we run it, we go to the vulnerable version of DuckDuckGo browser, and we navigate to that HTTP server which is running this exploit. So it's 192.168.1.199.8000, and so it says that, oops, something went wrong. I'm not sure whether it's visible or not, but it basically says, oops, something went wrong. Click here to navigate further. It's like you can play around with this content. You can put something else, whatever you want. This is just to demonstrate that, okay, the user will navigate to some other URL. And now once the user clicks, if you see, it says google.com/CSI. And the pop-up has been given. So now you are spoofing the origin of google.com, and the end user will believe that, okay, that is something has been coming from the actual Google service or the Google website. And you will went ahead and punch the credentials. And once the credentials has been punched, it is traveled back to the Metasploit terminal, which says that google.com/CSI, the username is admin, and the space with the password. So that's how it was being done, and both of the vendors have patched this issue so far. Moving forward, what could have been more wrong in this case rather than just getting the user credentials? So if you remember custom_JS, we talked on the previous slide. Now I have enabled a function in MSF module that says custom_JS. So if you don't like to just gather the username password in this case, probably you can write up your own JavaScript, and you can set custom JS to what malicious JavaScript you have written, and you can utilize them so that as soon as the victim try to visit your malicious URL, that JavaScript payload will be executed. So you can utilize hook.js from the browser exploitation framework, or you can write your own. So this was a very nice and straight pretty finding, that as long as you can trick your victim to visit the malicious HTTP server hosted by the Metasploit module, you have a chance of gathering the credentials or hooking the browser and playing around with it. So this was one of the findings which I figured out during my learning towards the modern browser. Moving on to the next one, we'll talk about the code execution. So I figured out this vulnerability in Firefox, but it was a duplicate bug. The reason why it was duplicate, because the Firefox team were already familiar with this, and they were already maintaining a track to mitigate this issue. So the approach to find this vulnerability was I was going and reading the documents, the developer documents of Firefox, and I figured out that Mozilla provides a component called as NSI local file. Now it's a component basically. I'll let you know what NSI local file is. So here is the reference, you can read about it. Firefox being an open source browser, they have each and everything detailed written in the blog or the developer edition. So Mozilla provides a component known as NSI local file. Now using this NSI local file, you can navigate to different paths in different platform, and you can query or perform or call any binaries. So basically using the NSI local file component, you can navigate to the path. It's like a directory traversal, and you can point it to any of the binaries to get it executed. The NSI local file component can be referred using a string called @mozilla.org/file local ;1. So this is how NSI local file can be called, and this basically creates an instance in the Firefox browser, which is known as contract ID. So using a little bit of tricking around, little bit of JavaScript, and using this contract ID with NSI local file, you can call and prompt cmd.exe within the context of the Firefox browser. So I'll just quickly give you an idea how this works. Now, this is one of the policy that NSI local file should not call the could not travel into your own system and navigate and execute certain binaries. But in this case, we were able to do so. So if you see, I've just added components with the name F. It can be foo or anything else, and use the NSI local file to create an instance. And using that, we actually initiated a path, which is C Windows System32 cmd.exe, and we said F launch. So as soon as you open up your Firefox browser, navigate to new tab, and you put this into your web console, this will end up giving you a pop-up of cmd.exe. So here's the video POC for same. This was the vulnerable version of the web browser. You open up a new tab, and you do an arbitrary write to the web console, and that pops a cmd.exe in the console. Now, as best of my knowledge, I was not able to exploit this remotely, but probably it may have a causes that if you're playing any sort of CTF or something else, this would be a little bit helpful. So again, but this was a duplicate bug, but there was a lot of learning in this case that how NSI local file works, and Firefox went ahead and passed this issue by not navigating the NSI local file and pointing it back to any of the binaries. So this was the another finding which I figured out in Firefox. It's an integer under overflow. It was a great learning in this case. So what integer under overflow is, if the integer value used is less than the minimum signed and unsigned integer in an array, that causes an integer under overflow, and that may lead to a segmentation fault. So what happened is, while fuzzing the NSS library of Firefox, I was using the Firefox, and I was browsing to an Nginx server hosted locally, which almost hosts nothing. It's like a small index.html file which says hello world. So what happened is, whenever I used to visit that Nginx server, it used to have a bad certificate, and when I add those exceptions, my Firefox used to get crashed. I went ahead, I analyzed the GDB backtrace, and I figured out, okay, this is something which is specific to my profile. So I'll let you know what happened is, if you have Firefox in your system right now, you can go to the settings and you can create a new profile. New profile is something that it behaves like a fresh installation of a Firefox browser in your system. So when I created a new profile and navigated to the same Nginx server, during the add exception, the new profile Firefox was not getting crashed. That means that the profile which I was using was getting crashed, and it has some sort of issue in my profile. So thanks to Mozilla team for helping me this to debug it further. So what happened is we did the analysis on cert8.db file, which stores under your Mozilla app metadata. Now cert8.db file is a security certificate that stores separately from your OS. Now this DB file doesn't have any of your secret keys, but like key3.db file, but it will have information such as whatever you have imported from your CA, your client certificate, and etc. So by looking at the cert8.db file, we concluded that there is something which caused my certificate database to be corrupted. And this happened because the Firefox implementation for the certificate database was written a long back ago. And there are certain places and certain functions in the certificate implementation, it doesn't validate the input. So I might have visited certain website where the metadata of the key length is longer than the as usual key length, which causes a crash in my certificate DB implementation. So that's how this vulnerability, the root cause of this vulnerability was observed. I went ahead, submitted the issue to Firefox, and a patch was done for this. The patch says that the ugly_split function will do a garbage collection in whenever you add exception, whenever you do anything else, and it will check whether if the metadata length is more than the key size which is defined in Firefox DB implementation. So that's how they implemented a patch for this. And yeah, being a part of bounty program, the bounty was rewarded for same. So talking about the next vulnerability, again I targeted Firefox, and the reason why I said because it was done by a few of my colleagues with me. So I would like to thank Sebastian and Robin. So we went ahead and we understand the caching mechanism of Firefox and how this works. So this is personally one of my interesting findings so far. So I'll just give you a quick glimpse how this works basically. Log into your Gmail account from Mozilla and perform your dynamic activity. I have used Gmail over here. You can use PayPal, you can use whatever you want. Once you log in, you perform your dynamic activity, just simply log out. And when I say log out, most of the people think that, okay, everything is pretty much secure because I have just logged out. But in this case, don't close your browser after you log out. Can you recall this URL? It says https:/mail/u/0. So whenever you log into Gmail via UI, like the web UI, this URL is the post URL post your login, right? So you need to have an idea about URLs which are post login, right? So I'll quickly demonstrate. I hope it's visible. So John logins into the vulnerable version of Firefox, and he opens his mail, and there is only one email for now in entire inbox, which is from Dhiraj demo for FF for caching. The email says that here are some secret details. And if you see the URL, which is mail.google.com/mail/u/0. Now this is the post login URL. Just copy it on your clipboard, and John will go ahead and simply log out and says that everything is pretty much fine. But over here, Firefox was vulnerable to a caching issue. What happened is, if you do view-source and you browse through that source code of the URL which we copied back, and you search for secret. If you remember the email which John received, it says that hey John, here are some secret details. It is being leaked back into your source code even after you log out from the browser. So similarly, anything or everything which you have sent, perform any dynamic activity, those all would be visible to this version of Firefox, which is vulnerable. We went ahead, we reported this. As best of my knowledge, this is not exploitable remotely, that you cannot trigger it remotely because you need to bypass same origin policy again in this case. But yeah, this is something which was an interesting find, where you can assume a scenario, you log into PayPal, did some transaction, you punched in your credit card details, CVV or anything, and you log out, but you don't close your browser. Someone could have went ahead, just view the source code of the post URL and may capture certain sensitive details. So how did the Mozilla mitigate this issue? They added a cache control in place. Now cache control is again a sort of garbage collection in this case. So once you log out from the any of the web services which are provided online, now the Mozilla will call the cache control function, and it clears all the cache from your browser directly. For few of the website, you can add the minimum age and maximum age, the duration, how quickly you want to clear the cache. So this was one of the findings we went ahead and submitted. Moving on to the next one, we'll talk a little bit about some low-lying vulnerabilities, about the research which I have done so far, that we figured out some of the small low-lying issues in this case. This is pretty much interesting. Again, I named it as I swipe right, and this still works in Safari. When I followed the responsible disclosure for the Apple, they went and said that they closed my responsible report as an informative. So rather than explaining, I would jump to the video POC. So this is the Safari version I was using that time. This still works in the latest version of Safari, so you can try it. You click sign in and you log into your Gmail in this case, again, because it's pretty much simple. You put your password, and in this case, again, John receives an email from a person which says fund transfer. Here is the CVV number and the card details, or any juicy information it can be. And John note down it in a notepad or anything else, and he simply log out. And once it log out, you have to use the multi-gesture, in this case using your 2 fingers in the trackpad, and you have to swipe right. And when you swipe right, you would be able to see the previous data which was being performed by John in this case. So you can assume now, if you're using PayPal or if you're using anything, if you have to close your browser from long time, this is some of the information which can be disclosed by just swiping right. When I submitted this vulnerability to Apple, they said that it is just an informative finding and they closed it, but I believe it might be useful in few of the corporate environment where IT administrative don't close their browsers very oftenly. We'll talk about a little bit of spoofing attack in this case. Now, spoofing is one of the most common technique used in red teaming a little bit to perform phishing activities and etc. So spoofing is a very important technique and a part of the low-lying fruits. So over here, again, I played around with different functions. So if you see set interval, now set interval is a function that is responsible to call different meta functions such as location, iframe, and etc. So if you say, I created a function called fake function which has location https duckduckgo.com and created the interval to call this location as 50. So what happened is, I have a video POC for this, and when I host it to a normal web server and browse to it, you can see, right, the interval time is so slow pretty much that the omni box in the sense the address bar, it says properly https duckduckgo.com, but the content says something else. It says that we definitely store your personal information ever. So this is one of the spoofing techniques which can be performed. So rather than duckduckgo.com, I can spoof mail.google.com, and if you click it, the interval is so much slow that the omni box will point to the actual URL, but the inner HTML content can be rendered anything which attacker would like to. So this was one of the finding in DuckDuckGo. I went ahead when DuckDuckGo had a bounty program in HackerOne, and there was a patch pushed for the same. What if domain have emojis? We all love emojis, right? We keep on sending them. So there are certain cases where Safari allows emojis to be in your DNS. You can actually buy a domain poop.com, poop with a emoji. So let's suppose if you see the two screenshots on the right hand side, you see paypal.com with a lock. Now that lock is actually an emoji. You can buy certain domains which actually looks like very much real in this case. So for now, only Safari supports emojis as a domain. Rest all browser change emoji domains to Punycode. So the person who are using Safari are vulnerable against these attacks. So you can buy domains such as Facebook with a green check, maybe. You can register a domain box.com with a box. And you can register certain domains with over here with the heart emoji.ws. If you navigate to ilove.ws, you can actually buy certain emojis which will allow you to register. This is again one of the technique used for phishing. In the similar fashion, you can perform attack, very old school attacks such as IDN homographic attack. In that case, what happens is you register certain domain name with some of the English character and some of the Russian character, because Russian characters have a little bit of similar looking English characters such as P and so on and so forth. So you can register domains with some English character and with a Russian character. So you can perform a IDN homographic attack in this case as well. Let's talk about web view attacks, how web view attack work and what web views are. Now, web views or WebKit, they both are different thing, but over here in a very simple manner, I would explain web view is a small mini browser that comes inbuilt in most of the application nowadays. For an example, if you have a Facebook mobile app in your Android and you click any of the links or the post, it opens up an inbuilt browser within the Facebook. Now that is that you can say it's a web view for a Facebook. Similarly, if you do it for Twitter, it opens up an inbuilt URL, but that is powered by Chrome. So if you recall the IBM Lotus Note, IBM Lotus Note is one of the alternative of Outlook, you can say, where you send and receive emails. Now IBM Lotus Note have used to had inbuilt browser. Now I started analyzing it further and did few of the denial of service attack by writing a small script. Now this is a while try and catch statement. If you read through this, it's pretty much clear that it's an infinite loop in this case. So what happened is when you visit this to your IBM Lotus Note, your IBM Lotus Note will get hang or freeze and utilize your CPU as much, like it will utilize a lot of CPU. Memory consumption would be a lot. So this leads to a denial of service in this case. And why this happened, because is if you recall the very first or third slide of when we started about the block called as rendering engine, when the rendering engine block is not capable of handling such infinite loop, it leads to denial of service attack. So in this case, the IBM Lotus Note Web Views rendering engine was not capable to render the infinite loop, and that causes the crash. Not crash basically, but that causes the hang and leads to a denial of service. So this is pretty much straightforward. I went ahead again and ported this to an MSF module so that can be used in different platform. You can just simply search for IBM Lotus Note in Metasploit module to utilize it. I have used MSF HTTP library which comes by default and utilize that to write the module. Similarly, there was another vulnerability called 1130. Now in this case, so there are two findings. It's 1129 and the another one is 1130. The 1130 had a malicious JavaScript which opens your file manager again and again even after you cancel it. So again, it was a denial of service. IBM went ahead and patched it. And to be honest, after that, I went ahead and submitted 2 to 3 vulnerabilities more in IBM WebView, and they stopped shipping the WebView in the IBM Lotus Note after that. So this is pretty much straightforward how I ported this. So you have a defined setup and you put your infinite loop statement over here in between, and you created a define on request URI that prints the status if anyone visits the malicious web server of yours, and that leads to a denial of service attack. So that's all from my side. This is what I have done so far, but there are always areas to explore, which even I am trying. So you can have a look on understanding the DOM of the browser, document object module. You can do fuzzing browsers specific to DOM, where Project Zero has some awesome blog on it. You can use or learn more about sandbox escaping techniques, where I am focusing it for now. You can do same origin policy bypass via source code review for the open source web browsers. You can participate to various bug bounty programs specific to browsers. In a simple way, you can just do site:/hackerone.com/browser. That will give you some published report from the Brave browser, because Brave has got a bug bounty program in HackerOne. So you would have a different mindset how other researchers are playing around. The second last point is one of my favorite point, that you can create a sandbox environment and you can compile your browsers, open source browsers, with the help of ASAN. Now, ASAN is an address sanitizer which captures the stack trace and which captures the vulnerabilities from your memory if you have any crash or something. So you can use web browsers in your day-to-day life with ASAN enabled, and you may end up finding certain nice bugs in this case. I would suggest refer bugs which are published by Chrome, Mozilla security advisories, when they have bunch of advisories pushed together. So when you visit certain advisories, there would be bug ID, and you can read bug ID about how researchers are playing around with browsers, or how they are bypassing the SOPs, and so on and so forth. So this is a quick areas to explore, and that's all from my side. If you have any questions, I'm happy to answer.
Any questions from the audience? Then we'll move on to the Slido.
Okay. The first one is, can this type of exploit be executed remotely? Can this work on the browsers like Tor? So I think this is for the web console one. Yes, for sure it can be used on Tor, but I'm not pretty much sure whether it can be used executed remotely, because Tor utilizes the Mozilla engine, so that whatever vulnerabilities you saw in my track is almost replicatable in Tor browsers. Which browser do you recommend for a safe web journey? Do you have mandatory settings to implement for safe browsing? Safe browsing, in the sense, you can use different browser. You can use Firefox Focus, which is one of the privacy browser. You can use that. There are no certain mandatory settings which can be enabled, but there are certain things which you can disable, such as WebRTC components and similar to that, if you are not using it. So that's pretty much clear. Does using the incognito or private browsing offer any security benefit? In this case, it doesn't capture the history or doesn't capture any cookies or something else. But I remember certain write-up for certain vulnerabilities where attacker, if you are using an incognito mode, there were certain techniques which I cannot recall for now, but they captured the traffic, at least from the incognito mode which is being generated, and whatever you are browsing. And I think incognito mode, there was a vulnerability back in Firefox that it stores some of the details in a backup-based vulnerabilities. So rather than using incognito, I would prefer using certain browsers which are specific to privacy. So yeah, for the exploits you have found, how much would they typically bug bounties be worth? So it depends. Basically, if you have a full-fledged remote code execution, I would prefer, rather than submitting it to Mozilla, I would go ahead and submit it to some third party, so that you get $5 to $6 digit dollar bounties. So in general, if you have a look on Mozilla and Chrome's bug bounty reward, they start usually from $1,000 and it goes on till 50, 60,000 or maybe. So you can just have a look on the advisories of Microsoft or for Edge and Opera, Chrome, and etc. I saw some of the test cases from LambCorp from book The Tangent Web. If you are presented, yes, that person, the creator of EFL, that was tweaked a little while submitting to it, and when I submitted this vulnerability to the Firefox, they went ahead and made it as a duplicate because he has already reported this vulnerability, which I was not familiar with. What do you think about the difference in the number of vulnerabilities detected between Firefox and Chrome? This is unpredictable for me right now, because if you go to the bugs.chromium.org and bugs.mozilla.org, you will find out the list of vulnerabilities are very much similar in both of them. So I'm pretty much not sure about this, because there are a lot of vulnerabilities getting patched in Firefox and the Chrome at the same time. Will the exploit work on the other browsers such as Opera or Microsoft Edge? I'm not sure which exploit you're talking about, but Opera utilizes the Chrome engine, and Microsoft Edge is altogether uses Chakra core. So there are chances that the bugs which are figured out in Chrome may work in Opera, but for Microsoft Edge, you need to focus more on the Chakra core. Yeah, that's it. Thank you.
Thank you, Dhiraj.